Which of these molecules has the most carbon atoms? A, B, C, or D? Right off the bat, it's clear that the bottom right molecule has 2 carbons and the bottom left has 1, because when there's no number subscript for an element in a chemical formula, it's secretly 1. So we'll cross out choice C, because that molecule can't have the most number of carbons if it has less than the D molecule. Beyond that, you may have noticed that each of these molecules are presented in different forms. One's a bond line diagram, one's an organic name, one's a Lewis structure, and one's a formula. And because they're in different forms, there are ways in which we can and probably should convert between each. And as we saw, the Lewis structure and chemical formula forms make it super easy to determine how many carbons we have. Thus, for example, we may want to convert our IUPAC name into a Lewis structure, and our bond line diagram can be converted into either one of the two easy molecular forms. Why don't we turn both into Lewis structures? And we'll start with the bond line diagram. A bond line structure really is just a summary model of a Lewis structure, and you may have noticed that each of the ends and bends are carbons. So we don't even have to finish our Lewis structure because we already know that our molecule has 3 carbons. In case you're wondering, this is what the final Lewis structure looks like, and there's a video in the description and at the end that shows you how to figure this out. Nonetheless, we need to cross out choice D because 2 carbons is less than 3, and we're left with the first 2 options. Lastly, we got to turn our organic name into a Lewis structure. But how do we do that? What's it going to look like? Well, let's break this down. Propane looks like this. It's 3 consecutively connected carbons, single bonded, and each carbon has as many hydrogens as it needs to reach 4 bonds. A methyl, on the other hand, is an extension, an attachment of a CH3 group. And 2-methyl simply tells us that we attach this methyl group onto the second carbon of our propane. And no matter how we number the carbons on the propane chain, the middle carbon will always be the second carbon. And we've just created 2-methyl propane. It has 4 carbons, and if we compare its carbon count to the others, it has the most of all the molecules to choose from with 4 carbons, versus 3, versus 2, versus 1. Therefore, the correct answer is B. 2-methyl propane has the most carbons of all these molecules. Check out the video in the description to find out exactly how we can navigate from bond line diagram to completed Lewis structure with all of its features, including the dots.